Today we are going to be looking at the water versus cyclohexane lab. Dun dun dun. Going into this lab, one very big, the biggest concept you need to keep in the back of your mind the entire time is that water is a polar structure and cyclohexane is a non-polar structure. Okay. From that information, we're going to look at 7 different examples of how these molecules interact with themselves. And then at the end, we'll do a little bit of a review and see what kind of similarities or differences we see throughout the experiments. now that you've had a chance to look at both water and cyclohexane and how they interact with each other, let's take a quick look at some of the reasons that happen. Your teachers will go in more detail, but right now, biggest thing to keep in mind, water, polar structure, okay? And in fact, this is going to form hydrogen bonds, technically 2 of them, okay? And cyclohexane is nonpolar, so it's going to have London or dispersion forces. Okay, so big picture, there you go. And I think just kind of giving away the answer, polar bonds, these are stronger. Cyclohexane, the London forces, hydrogen bonds are very strong, London forces are very weak. Okay, so let's move on. Station 1, let's talk about the evaporation. We saw that the cyclohexane evaporated a lot faster. Okay, evaporation is simply these molecules getting enough energy to rip off. Well, if they're very strong, like very strong magnets holding on, they're not going to want to leave. Okay, water's very strong, they hold on to each other. Cyclohexane's very weak, they rip off very easily. Okay, station 2. Station 2, we talk about adhesion, cohesion. We saw that if we compare these, water went up higher. This is a capillary action, okay? I think the easiest way, the simplest way, I know it's excluding some information, but if you think about these molecules holding hands like this, water being very strong is able to pull their friends further up that glass. Now, there's other things that that come into play about the polarity of the glass and the cohesion, everything. But if we're talking about the interaction of these molecules, just picture the molecules kind of pulling each other up that tube, that capillary tube. Okay. If we look at station number 3, now this one should be very, very evident. You had, if this down here, this would have been considered the cyclohexane, okay, because it just flowed over the side very easily. Up here, this is where we saw that big bubble from the water, okay? Again, I have these molecules holding on really tight to each other. They're not letting each other fall off the side, okay? So again, we're talking about very high surface tension there. Station 4, 2 things happen in station 4. We saw the cyclohexane, usually the term kids use is it melts. Okay, it kind of just goes right through the wax paper. Okay, why it does that is that, remember, like dissolves like. Okay, polar dissolves polar, non-polar dissolves non-polar. Well, we know that water is polar, we know cyclohexane is non-polar. So since that cyclohexane went right through the wax paper, we can infer that that wax paper is non-polar. The water stayed in a bead on it. And then I could even take that toothpick, and I was able to kind of take that toothpick and run it through, and it stuck with it. Again, that has to go with that surface tension, that adhesion, those molecules kind of holding on to each other, pulling each other along. Okay, station 5. Again, we have water is charged. When we took that, the rod, ours looked like this black plastic rod here, we charged that up, and we put that near the water stream, we get this, okay? Again, it charges it up, and then it's able to pull that water towards it. Again, it's like opposite magnets, okay? You get a positive, negative charge, they're attracted to each other. There you go. Cyclohexane is not polar, it has no charge to it, so it just is a stream that goes straight down, okay? When we look at the vortexes, okay, we saw this would have been considered the water. Okay, this one's kind of tough to look at, but the water, it's kind of, again, if you think about it, it's harder to pull that water down, okay? Cyclohexane formed a really big vortex very fast because you simply could pull it down really hard, okay? Water doesn't form as big as one as quickly as cyclohexane. Station 7, kind of cool. This is water. Okay, water has very high surface tension. That's why it hurts when you belly flop. Okay, you have to break through those bonds. I like to think about the old school game Red Rover. Okay, Red Rover, let Johnny come over. And Johnny tries to run through, and you try to clothesline him and break his neck, and he tries to run through. Well, it depends who you're playing that game of Red Rover with. Okay, very strong people, it's going to be very difficult to get through that game of Red Rover. Very weak people, you can run right through it. Water is considered a game full of strong people. It holds that paperclip on the surface. Cyclohexane does not hold the paperclip. So again, very brief, very quick explanation of all these. It all comes back to the general idea that water is polar. It forms hydrogen bonds. Cyclohexane forms London forces, are very weak, and then we could see how those reactions happen throughout the experiment.